Today, our focus for this lesson is going to be on building fluency with adding and subtracting decimals by using the standard algorithms. So the first problem that we're going to take a look at is on page 325, and it says, Julie and Doug are building a treehouse out of wood boards. Julie has a board that is 1 and 1500 meters long, and Doug has a board that is 7/10 meters long. What is the combined length of the board? So when we do this, when we're adding um, the two lengths of the board together, because it says what is the combined length, that tells me that I'm doing addition. When I add this, I need to make sure that when I add that I line up my place values. That's the most important thing when I'm adding and subtracting, is that the decimal is lined up and place values are lined up. So when I add this, what I'm going to do is I'm just going to do 1.15, and then I'm going to put my decimal and 7, put a 0 in front as a placeholder, put a 0 behind as a placeholder, and then I'm going to add. So 5 and 0 make 5, 1 and 7 make 8. Bring down the decimal stays in the same spot, it doesn't ever move, and then 1 plus 0 is going to be 1. So my answer is 1.85. But because it gave me a label or a unit of length, I need to make sure that my answer has a unit of length as well. We're still turning problems or completing problems and not including that label, that unit of measurement. So in this case, it's meters. Sometimes it could be balloons, it could be puppies, it could be hours. You need to make sure that if it asks you for a label, or if you're doing a word problem, that you are including that label. Okay. So the next problem that we're going to take a look at is going to be on page 326. It's going to be the top of the page. And it says Kim and Martin swam 50 meters. Martin took 0.26 of a second longer. So seconds is my unit of measurement in this one. Then Kim. What was Martin's time in the race? So to do this, I'm going to go ahead, and because it was longer, it's going to be more time, so I'm going to be adding. So Kim's time, if I look at the picture, was going to be 50.9 seconds. Notice right now my place values aren't lined up, so I need to go ahead and I need to line up my place values. So I'm going to do 50.9 as my top value. I'm going to put my decimal, do 26, and then fill in the zeros as placeholders as I need to. Now I'm going to go ahead and I'm going to add. 0 and 6 is 6, 9 and 2 is 11. I regroup the 1. I bring down my decimal. 1, 0 and 0 is 1. 5 and 0 is going to be 5. So my answer on this one is 51.16 seconds is going to be Martin's time. Okay, so because it said longer, it's still going to be an addition problem. If we take a look at the convince me on the bottom of the page, it says, suppose Martin finished the race 26 hundredths of a second before Kim. What was Martin's time in the race? Use an estimate to check that your answer is reasonable. So I still have this information, but now it's going to be he was faster than Kim. So because he was faster than Kim, we're not going to be adding, we're going to be subtracting. So I'm going to go ahead and I'm going to line up. And right now, because we're not working with negative numbers, my larger value is going to go on the top because I'm looking at how much faster Martin was than Kim. So I'm going to subtract, because I've already done my placeholders. That makes it easy. 26 hundredths of a second. Go ahead and do some regrouping. 10 subtract 6 is 4. 8 subtracts 2 is going to be 6. So the time that he has is going to be 50 and 64 hundredths of a second. We need to go ahead and we need to estimate to see if that answer is going to be reasonable. So my estimation is going to be 50 and 9/10, and I can go ahead and I can leave it at 9/10. So if I do 50 and 9/10, I'm going to do the estimation in blue. 50 and 9/10. Subtract 26 hundredths of a second is going to round to 2/10. And when I do that, I get 0.7 difference. So it's going to be 50.7. 50.64 is near 50.7, so it is a reasonable answer. All right, moving into your guided practice, making sure that you guys are getting your work recorded as we go. So it says number 1, how is adding and subtracting decimals similar to and different from adding and subtracting whole numbers? So when we add and subtract decimals, so I need to make sure that when I add and subtract decimals that I line up the place value. So this is my differences, line up place value and decimals. My similarities are going to be that I use regrouping and symbols the same way. So I add the same way, I use regrouping the same way. The only thing that really is different is bringing down the decimal and making sure that my place value is going to be lined up. Okay. And 2 through 5, we're going to find each sum or difference. So when we take a look at finding each sum or difference, so the first one that I'm going to do is I'm going to do 5.9. So number 2 is 5.9 or 5 and 9 tenths added to 2 and 7 tenths. It's nice. They both go out to the tenths place value. So I just need to make sure my decimals lined up and my place values are lined up. 7 and 9 is going to be 16. So I put down the 6. I regroup the 1. Make sure you go ahead and bring that decimal down as your placeholder. And then 1, 5, and 2 is going to be 8. So my answer is going to be 8 and 6 tenths. The next value that I have is 4 and 1/100th, subtracting 2 and 95 hundredths. Notice that when I wrote this problem vertically, I made sure that my place values were lined up because both values went out to the hundreds place value. I didn't have to add any placeholders. And then I subtract. I need to regroup across the 0. So 4 becomes a 3, 10 or 0 becomes a 10, and then 1 becomes 11. So 11 subtract 5 is going to be 6. 9 subtract 9 is going to be 0. And then 3 subtract 2 is going to be 1. So my answer is going to be 1 and 600th. Okay. Number 4, I have 2 and 57 hundredths added to 7 and 706 thousandths. Notice in the 2 and 57 hundredths, I went up to the hundredths place value. So I'm just going to add a placeholder there. And now my place values are the same. So 0 and 6 is going to be 6. 7 and 0 is going to be 7. 5 and 7 is going to be 12. Put down the 2. I regroup the 1. Put my decimal down as my placeholder. 1, 2, and 7 is going to make 10. So my answer is 10 and 276 thousandths. Okay. The last one that I'm going to do is I'm going to do 15 subtract 6.108. So this one's a little bit different because I don't have any zeros after the 15. So we remember that the decimal always goes after the 1's place value, and then I can just add zeros, and then I just need to regroup across the zeros. So 15 becomes 4. This becomes 9. This becomes 9. That value is 10. 10 subtract 8 is going to be 2. 9 subtract 0 is going to be 9. 9 subtract 1 is going to be 8. Put down my decimal. And then 14 subtract 6 is going to be 8. So my answer is going to be 8 and 892 thousandths. Now to check the answer, if I wanted to go back through and check the answers, I can use inverse operations to make sure that my answer is correct. So just remember that if you need to perform a check to offer proof, your inverse operations is going to be your check. So for your independent practice today, you are going to do 7 through 13 odd. So I'm only looking at the odd numbers on 7 through 13. And then you're going to do all of 14 through 17. When you're finished with that, you need to go ahead and turn in your practice and then work on your daily review.